Generative artificial intelligence can take the hard part out of learning. That's not the feature, that's the danger. Because some hard parts are barriers we should remove, and some hard parts are the learning. Remove the wrong one and you don't make school easier, you make it stop working. So here's the line. And every single use of technology, including artificial intelligence, sits on one side of it. Above the line, the barriers. The things stopping a student from getting into the work. Below the line, the effort, the cognitive work that is the learning. Get this line right, and artificial intelligence is the best support tool we've ever handed a teacher. Get it wrong, and it quietly dissolves the thinking that makes school worth doing in the first place. So let's walk both sides carefully. Let's start by exploring above the line. These are the barriers that sit between a student and the work. They are not the work, they're what stops a learner from ever reaching it. Many of us have multilingual learners in our classes, students whose thinking is sophisticated but whose English is still developing. Without support, brilliant ideas never make it onto the page, and we end up marking the English, not the thinking. We also have students with reading mechanics that get in the way, diagnosed or undiagnosed. For these students, decoding eats so much working memory that there's nothing left over to comprehend with. The barrier isn't the ideas, it's the machinery of getting to them. Executive function. Now, this is one both teachers and students struggle with in a busy school. We can think perfectly well, but sequencing the steps to actually get the task done is a different skill entirely. So we scaffold the planning and the organization so that the thinking has somewhere to happen. Information access. Let me make this one concrete, because it's the one we underestimate. Picture a Year 9 history lesson. You want them analyzing the causes of the First World War, so you hand them a historian's article, and it's dense, long subclauses, specialist vocabulary, 300 words before the argument even shows up. 40 minutes later, half the room still hasn't made it past paragraph 2. And here's the thing, that they haven't done a single second of historical thinking yet. They're still trying to work out what the sentence says. That's the barrier. The source material is pitched way above the reading level, but the thinking you're asking for is well within their reach. They just can't get to it. So we use AI to give them a plain language version, or to surface the passage that actually matters in a wall of search results. And suddenly they can spend the lesson doing history instead of decoding prose. The tool gets them to the source. It does not do the analysis of the source. That part is still theirs. And finally, motor access, voice control, dictation, for students whose handwriting or typing gets in the way of what they actually want to say. Now, here's the part I want you to sit with. This is universal design for learning. This is Caster's framing. And the entire point of UDL is that we are not only talking about diagnosed conditions. Think about the curb cut. We lowered the curb for wheelchair users, and it turned out to help the parent pushing a pram, the traveler with a suitcase, the delivery driver with a trolley, designed for the margin, better for everyone. Captions were built for deaf viewers. Now half the room watches with them switched on. It's the same here. Plain language access helps the dyslexic student and the kid who's exhausted and the one who missed a fortnight sick. Dictation helps a student with a motor difficulty and every student whose ideas outrun their typing speed. Barriers are not a special education footnote. Remove them by design and you lift the whole room. What's good for one is good for all. And notice, every one of these is something we already agreed technology should remove. Long before AI entered the conversation, glasses, hearing aids, spell check, calculators, past a certain point. We have been drawing this line for 50 years. AI is simply the newest tool to sit above it, and now, below the line. Here I want to slow right down because this is the whole argument. Effort is not the friction before the learning. Effort is what builds the schema in long-term memory. Take it away and you haven't made learning easier, you've made it not happen. 5 things live down here: retrieval, generation, argumentation, evaluation, and self-explanation. Retrieval, pulling knowledge back out of memory. Robert Bjork's work, 50 years of it. Every single time a student retrieves, the memory gets stronger, and every time something else does the retrieving for them, it gets weaker. This is the engine underneath spaced practice, the testing effect, low-stakes quizzing. It is not optional, generation, making the answer, not finding it. That move from a blank page to a first sentence, and that struggle is the thinking. AI is exceptional at producing fluent text. So if a student never has to face the blank page, they never build the muscle that gets them across it. And notice, generation is itself one of Bjork's desirable difficulties. The discomfort is the mechanism, argumentation, building and defending a position, choosing your claim, anticipating the counter, marshalling your evidence. This is where understanding goes public. And it is one of the most uncomfortable cognitive moves a student ever makes, which is exactly why they reach for AI to do it for them: evaluation, judging quality, weighing evidence. Margaret Behrman and her team at Deakin call this evaluative judgment, and they argue it is the capacity most at risk in an AI world, because AI is fluent, it's confident, it's beautifully formatted. Students need the judgment to ask a very simple question: is this actually any good? If they outsource the production and the evaluation, there's nothing of the student left in the work. And self-explanation. Articulating your reasoning to make your thinking visible to yourself first and then to others. The research here is striking. Cheese work. Students who explain their thinking to themselves understand more deeply than students who simply consume the same content. These 5 are not the gateway to learning. They're not the prerequisite for it. They are it. So let me show you what's actually happening underneath that effort. A student meets something new. A sparse first sketch in working memory. A few nodes loosely connected. It feels fragile, because it is. Day 3. They retrieve, and they struggle to pull it back. That struggle is uncomfortable. It feels like not knowing, and that feeling is precisely why it works. Each retrieval strengthens the connections and adds a few more nodes. Day 7, they retrieve again as we created space. The schema is denser now. They start to feel they know it, but that knowing is still fragile if they stop here. Day 21. Transfer into long-term memory. A stronger, denser schema. One the learner can actually use in a new context. That is understanding. Now notice what built it. The struggle, the retrieval, the effort spaced over time. Take any one of those away, and the schema simply doesn't form. You get the feeling of learning, with no structure underneath it. That's the trap Paul Kirschner names in instructional illusions. The things that look like learning very often aren't. This is the diagram I come back to every time I'm tempted to smooth a lesson out. Smoother isn't better. The struggle is the schema building. Here's what makes this genuinely difficult. The same activity with same title, same instruction, can land on either side of the line, depending entirely on how the student uses the tool. That's Leon Ferz's insight, adapted from his AI assessment scale. And the cleanest way to tell the two sides apart comes down to 2 words. Above the line, cognitive offloading. You hand the tool the low-value load, so your working memory is free for the actual thinking. Below the line, cognitive outsourcing. You hand the tool the thinking itself. Same tool. Opposite outcome. In a research activity, offloading is using AI to locate sources and then evaluating and synthesizing them yourself. Outsourcing is asking AI for the answer and never knowing or checking where it came from. When a student is problem solving, offloading is asking AI Socratic questions when you're stuck and then working out the answer yourself. Outsourcing is pasting the problem in, copying the solution, and understanding nothing. When reflecting, offloading is talking your reasoning through with AI to test and refine your own ideas. Outsourcing is asking AI to write the reflection on your behalf. What's important with feedback is making the judgment about whether it improves the work or not. Outsourcing is every change without judgment, and offloading is treating AI feedback as one perspective and then deciding which suggestion to take. These are all the same activity but with a completely different cognitive reality, and this is where the work for teachers lays. You cannot tell which side of the line a student is on by looking at the assignment title. You can't even tell by looking at the finished product. You can only tell by looking at how the student worked. So we stop policing the tool and we start redesigning the work. AI is designed to reduce the barriers to learning, not the effort of learning. That's not a policy line. It's a design line. If how the student worked is what matters, then the ask is where we draw the line. In every classroom, every day, 5 cards. Each one protects one of the efforts. And each one turns the verb back to the learner. These cards aren't in any particular order. I've just laid this in this fashion to help with recall. When students use AI for generation, AI can produce the project, but it cannot produce the path a student took. So we should be asking students to demonstrate the process, not just the product. Ask them to submit your 3 discarded ideas alongside your final answer and explain why you dropped them. In practice, that's a design brief where the rejected concepts get graded, not just the polished one. It's a draft history. It's the false starts. AI can hand you a destination. It can't hand you the road you walked to get there. The discarded ideas are the generation. The 2, self-explanation. We know that AI can give an answer, and new models can even explain and justify the reasoning behind it. So we should ask students the why, not the what. Where did you almost go wrong, and how did that change your thinking? In practice, that's a 2-minute voice note talking through your reasoning, because the moment a student has to narrate their own thinking, a fluent AI answer stops being enough. The 3. We can also put AI inside the task as a thing to be evaluated, not as the source of truth. Here are 3 AI responses. Which is strongest? And why? In practice, you hand students the AI output, and judging it becomes the assignment. This is Behrman's evaluative judgment, protected directly, because the student can't outsource the evaluation when evaluating is the whole task. The 4. Retrieval. AI doesn't have your week, your classroom, or your community. We spent time unpacking this in the previous slide. Connect this concept to something you observed in class this week. In practice, that means anchoring the abstract idea in a shared, lived moment. The experiment that failed on Tuesday, the debate that got heated on Thursday. AI can retrieve the entire internet. It cannot retrieve your Tuesday. Only the student can do that. Finally, argumentation. AI can write a defense. It cannot stand at the front of a room and be questioned. Be prepared to teach this back to the class in 5 minutes. In practice, the room becomes the assessment. Live questions, follow-ups, the counter-argument you didn't see coming. This is the most AI-proof task we have because presence cannot be pasted. Take a moment to notice the pattern across all 5. Every card is a verb the learner is doing. Generate, explain, judge, retrieve, argue. Never a verb the AI is doing. We don't ban the tool. We design the ask so the thinking has to be theirs. The ask is where the line gets drawn, as in every classroom, every day. So that's the framework. Now I want yours. Drop it in the comments. What's one assignment you've redesigned so that AI can't do the thinking for the student? The most useful ones I'll pin, and I'll pull the strongest into a follow-up video. Lastly, I've developed a free iPad app called Barriers that's linked in the comments. Check it out and see if it can help you reflect on the unintentional barriers we built into our practice.